Hi, everyone. I'm excited to share my final project, Standing Spot. In this project, our goal is to make Spot stand up and walk around, and we're inspired by animals that can use their bodies in very creative ways. We're going to formulate this as a trajectory optimization problem using a direct transcription method. And in particular, I want to focus on why contact makes this difficult. And the reason is our robot is going to obey a different dynamics equation depending on which feet are touching the ground. And this is a problem for two reasons. First, our optimizer can't handle these OR constraints. And second, we don't want to write down all of these dynamics equations. So solutions to this problem is that we can actually use a contact schedule. So we can tell the optimizer exactly when each foot is going to be on the ground, and we can solve for the contact forces as part of the optimization given the schedule. So the contact forces enter the manipulator equation through this contact Jacobian and also have other constraints on them. So what does the contact schedule look like for standing? Well, initially, all 4 feet are on the ground, and then only 2 feet are on the ground. For a walking limit cycle, it gets a little bit more tricky. So initially, both rear feet are on the ground. Then the leading foot leaves the ground and drops back down, and the lagging foot sort of catches up after. And because this is a limit cycle, at the end, both feet are again on the ground. Similar situation for a hopping limit cycle, which is the second gait I tested out. So both feet initially on the ground, then they leave the ground, and then they land back down. Now, the first thing I tried was getting Spot to stand up. And this turns out to be a very underspecified problem if you don't provide a lot of guidance. So the first thing I tried was let's just get the center of mass to be above some threshold. And I ended up getting some really wonky results, as you can kind of see. So one idea I had was to first solve for a upright fixed point, where we know that the robot is standing up, and we can apply some U to keep the robot stationary. Now, this makes optimization much easier because we have a Q0, a Q final, and the optimization just needs to fill in the details. Okay, let's take a look at some results. Great, so I think the results look really fun, although the physics are a little bit suspicious, and that's because I'm painting out these trajectories. My main takeaway from this project is that trajectory optimization is actually really challenging. I spent a lot of time trying to get all the constraints right. I spent a lot of time turning on and off different forces, trying to debug my optimization problem. And I was also facing issues with integration error, even when rolling out very simple trajectories, like getting Spot to just stand still in one location. And so I think, in particular, the integration error suggests that we need something like NPC to turn our trajectory into a controller, although I think that's still difficult to get working in real time because this optimization problem takes several minutes to solve. Thanks.